So welcome to statics and mechanics of material. First, I would like to discuss some important concepts which are related to vectors. So what are vectors? Can someone tell me? Vectors have magnitude and direction. Now, what do I mean by magnitude and direction? Say, for an example, if you are at point A, if you want to go to point B, you need to specify the distance between A and B, and you need to specify where B is located with respect to A. So you can't just say that go 5 meters from A and you'll reach B. You have to tell exactly, you have to go 5 meters in northeast direction so that you can go from A to B. So if you want to go from A to B, you need to tell that the dimension or the magnitude, I'm going to call this 5, and you need to say which direction you need to travel. Compared to scalars, scalars only have magnitude, so no direction. Now a vector has a tip and the tail. So now please note, you are going from A to B. So you would write starting from A, going towards B. So that is how you will write it. Now, whenever you have a vector, the magnitude of this vector indicates the value, which is the absolute value of its projection. What do I mean by that? I'll explain to you in just a second. So imagine if this is the vector and if this angle is 30 degrees and this is X, this is Y. Now what I'm going to do is I'm going to complete the right angle triangle. Okay, I'm going to complete the right angle triangle. Whenever you construct a right angle triangle, the perpendicular should always be at the reference plane. So my reference plane here is X and Y. So what I'm going to do is I'm going to draw a vertical line here. I'm going to draw a horizontal line here. I'm going to draw a vertical line here. I'm going to draw a horizontal line here. Please note, so triangle ACB is a right angle triangle. Do you agree with me? Triangle ACB is a right angle triangle. Now, probably you studied in high school trigonometry that Pythagorean theorem, which is AC square plus BC square is equal to AB square. Do you agree with me? You also studied sine and cosine relationship with the perpendicular right angle triangle. So if this is 30, or I'm gonna, this sine 30 is equal to BC divided by AB. Do you agree with me? Cosine 30 is equal to AC divided by AB. Do you agree with me? Now, what it means, and I'm going to move this a little bit here. What it means is if I give you value of AB, and if I ask you the value of AC, if I give you value of AB, say if AB is equal to 5, you can use sine 30 is equal to BC divided by AB. Thus, BC is equal to sine 30 times AB. Sine 30, as you know, is 1/2. AB is 5, so BC is 2.5. If I ask you, you can use the cosine relationship. Cosine 30 is equal to AC divided by AB. So if I want to find out AC, cosine 30 multiplied by AB, and cosine 30 is square root. Can someone tell me what is cosine 30? What is cosine 30? Use your calculators. Or you can use the relationship sine 30, sine square 30 plus cosine square 30 is equal to 1. 1/4 plus cosine square 30 is equal to 1. So cosine 30 is √3/2. The last relationship, which is cosine of 30 is equal to BC divided by AC. Now this math is extremely important because the vector that you might be dealing with could be a displacement. The vector that you could be dealing with force. The vector that you could be dealing with maybe is like acceleration or velocity. As long as you have a vector and you have a coordinate frame which is perpendicular to each other, and which is extremely important, okay? Coordinate frame, this coordinate frame is perpendicular to each other. You can resolve the vector along the x direction or along the y direction. Everyone understood this? Now you can do the exact same thing for a different triangle. So if I give you maybe I give you a triangle A, D, and B. I give you a triangle A, D, and B. Now, what is the difference between the triangle A, C, D and A, D, B? If you look at those two triangles, they are kind of flipped. What do I mean by flipped? Since this angle shown over here is 30 degrees, do you agree with me that this angle is 60 degrees? Since this angle is 30 degrees, this angle is 90 degrees. Triangle, total sum of angles is 180. Do you agree with me that this is going to be 60 degrees? Now, if I ask you what is the resolution of vector on AD, what is the resolution on vector AD? Can you see that I can write this something like 5 cosine 60. C stands for cosine. 5 cosine 60. Cosine 60 is same as sine 30. It means the distance AD and distance BC is the same. Only thing is, in one case, I have used a sine relationship, and in other case, I have used a cosine relationship. Everyone understood this? At the end of the day, the answer is going to be the same. Similarly, if I were to ask you what is BD, you can say 5 sine 60. S stands for sine, 5 sine 60. Everyone understood this? This is extremely important. Now, other important thing which is not explained properly, which I want to emphasize, is AC and CB are the components of AB. Why are those components? Imagine that you are at ISTB 12. You want to go to technology center. So I can say that if you want to go from ISTB 12 to technology center, you can follow this path AB, or you can follow the path AC, turn 90 degrees and go CB. Everyone understood this? Some of you may say that is not the only way. What I could do is I can go from A to D, and then I can go from D to B. So in order to go from point A to point B, I have three options. You agree with me? At the end of the day, if you take the diagonal, the distance that you travel would be less than the summation of the sides. That is the triangle principle or triangle equality. So diagonally, you can travel, or you can travel horizontally, you can travel vertically, or you can travel vertically and then you can travel horizontally. Everyone understood this? Now, this is actually very important. Because please try to understand what I'm saying, that if you want to go from point A to point B, first you need to go in this direction. This is the direction of the arrow. You agree with me? Then turn 90 degrees and go in this direction. Now understand, AC is a component, a piece of AB. CB is a component or a piece of AB. Essentially, these are the component vectors, and you need to follow this convention AC. Why AC with an arrow pointed towards C? You are starting from A, going towards C. Here, you are starting from C, going towards B. So I can write this vector expression as AC plus CB. Please note, is equal to AB. Are you with me so far? So you are starting from A, going towards C. You are starting from C, going towards B. So I want to look at this vector expression. The vector sum is go from A to C, go from C to B, which is same as going from A to B. Everyone understood? It is extremely important. Look at the signs of the direction of arrows. Resultant will always be closing the vectors. Resultant will always close the vector, which means if you look at A to C, arrow pointing towards right, C to B, arrow pointing towards upwards, and you will see that arrow from A to B is going from in the direction which is northeast. Everyone understood this? That is a valid vector sum. So this vector expression is valid only in this case. You can do the exact same thing. You can draw the arrows here. You can draw arrows here, and you can write another expression AD plus DB is equal to AB. And I want you to observe the pattern D, D. Everyone understood this? That is the basic concept of vectors. But story does not end here. As a matter of fact, we are just getting started. So imagine, let's talk about a coordinate plane. Now, first and foremost, why do we have coordinate plane axes perpendicular to each other? Why can't they be at any other angle? Why do they have to be perpendicular to each other? Why x is perpendicular to y? Yes.
Because perpendicular and increase the angles that are traveling on one axis relative to the other.
Right. So to explain what we said, these two axes are independent, which means travel in x does not influence travel in y. Travel in y does not influence travel in x. So essentially, these x-axis and y-axis, as a matter of fact, z-axis, they are perpendicular because they are independent. One axis does not influence the other axis. Everyone understood this? But I want you to understand, as soon as your axes are tilted, you realize that motion in one axis is influencing the motion in other axis. You don't believe me? Give an example. Imagine that your force is resolved something. We are forcing in this direction. Or if you are moving a particle in an inclined direction, it means that particle is moving in its perpendicular and horizontal direction. That cannot happen when the particle is moving in vertical plane or in horizontal plane. So that's why these coordinate axes are perpendicular. Now we use right-hand coordinate system. So this is going to be positive x. This is going to be positive y. This is going to be negative y. And this is going to be negative x. Now, one important thing, whenever you see a vector, no matter where the vector is, visualize this coordinate system and place it at the tip of the vector. So for an example, if you have this vector, something like this, then what you do is you take this coordinate system and place it over here. Why is this important? Because once you do that, you know that the x component of this vector is positive. So this is positive x component. Y component of this vector is also positive. If you have a vector going in this direction, and it is extremely important because we are going to get vectors in 3 dimensions. So we need to understand whether x component is positive, y component is positive, or z component is positive. So first thing, you should imagine this coordinate frame and place it where the vector starts. And as soon as you do this, now you know that the x component of this vector is negative and y component of this vector is also negative. You agree with me? Now, why is this important? Imagine, and we will work out the point, why this simple exercise is very important. If I give you vectors like these, okay, I say I have a vector in this direction, then I have a vector in this direction, and what I want you to do is, I want to find out the resultant or the sum of the vector. I want to find out the sum of the vector. If you want to solve this problem, how would you solve this problem? First, you are going to take this coordinate system. So I'm going to call this vector A, B. I'm going to call this vector B, C. And I want to find out the final resultant vector. So to do that, what I'm going to do is, first, I'm going to draw a coordinate frame here where the vector starts. Coordinate frame here. And then I'm going to draw another coordinate frame over here. You agree with me? Let me give you some angles. Say this angle is 45 degrees. This angle is 30 degrees. So the problem goes something like this. Problem. Find sum of AB and BC. The problem can also be worded as find resultant of vectors. The problem can also be worded as oh, that's a question mark. Oh, sorry. Okay, I should draw better. Now, how would you solve this problem? The way you would solve this problem is, please understand, one vector, first and foremost, you have to solve the vector equation, which means this is the point where the first vector starts. This is the point where the first vector ends. Second vector should start where the first vector ends. First vector start, first vector end. Second vector start, second vector end. So B. So can you see that finally you are going to get A, C. Are you with me? Now remember, dollars to dollars, pesos to pesos. These two vectors are not parallel. These two vectors are not perpendicular. So in order to sum these two vectors together, we need to use a consistent coordinate system. So what did I do? I took my coordinate frame and I placed it over here. I took my coordinate frame and placed it over here. Do you agree with me? Yeah. Based on what we did so far, I want to ask you a simple question. And let me tell you, I'm not going to teach you anything that you don't know. You already know all this stuff. I will just make you aware that you have seen this concept throughout your high school. Statics and mechanics of material is high school level stuff. As a matter of fact, I studied that when I was in high school. So first and foremost, my question to you is this. This is my coordinate frame. 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 I'm going to call this X. I'm going to call this Y. What is, let me give you the vector values, say 5, and I'm going to give you 6. So magnitude of AB is 5. Magnitude of BC is equal to 6. Can someone tell me what is this distance? What is this? This is a right angle triangle. So if I want to find out AX, that would be, yeah, correct. This would be 5 cosine 45. Now here is the important question. Is this 5 cosine 45 is in positive x direction or the negative x direction? Good. So do you agree with me that this vector, which is vector AX, is in the positive x direction? Do you agree with me? Now let's go further. And you know my next question. Can someone tell me what is this? XB. Yeah. 5 sine 45. And which way the arrow should point? Upwards. Very good. And can you see that this actually represents a vector equation AX plus XB is equal to AB. Do you agree with me? Once again, the reason we placed this coordinate frame at the beginning of the vector so that I know whether the X resolution is positive or negative. Y resolution is positive or negative. And this will be abundantly clear in next part. Now, you can solve it multiple ways. So, I want to find out the component. Let me write X and Y. Again, this is X and this is Y. I want to find component of BC on X and Y. What should I do? What I want to do is, in other words, I want to resolve BC on x-axis and I want to resolve BC on y-axis. What should we do? Yes, first step is always draw the perpendicular either on x-axis or on y-axis, so that we complete the right angle triangle. We agree with me? We have to first complete the right angle triangle. Now it's up to you whether you complete this right angle triangle or whether you complete this right angle triangle or you complete both. Doesn't matter. So I will actually complete this right angle. Now with the same logic, can someone tell me what is BY? What is BY? What is BY? Yes. 6 cosine 30. 6. Can someone tell me? Wait. Yeah, I'm getting there. I'm getting there. Not so fast. What is here? 6 sine 30. You agree with me? Now here is the observation. This is positive x. This is negative x. This is positive y. This is negative y. Do you agree with me? I'm going to explain this once again. We had this vector. We placed the coordinate system where the vector started. We drew a perpendicular line. Doesn't matter whether you draw perpendicular like this or whether you draw perpendicular like this. The concept is going to be the same. We found out the component. Note, the component of this vector is in the positive x direction. Component of this vector is in the positive x direction. That's why this component is positive. I will write this down here. You agree with me? Component of this vector in the vertical direction is the same direction as positive y. So this is positive. Everyone understood this? Now what happens here? The component of this vector is not in the positive x direction. It is in the negative x direction. You agree with me? That's why this component will be negative. Component, the y component is in the same direction as positive y. So this component is going to be positive. Everyone understood this? I'm going to repeat this one more time. When you place the coordinate system where the vector started, you find out the components of this vector or resolutions of these vectors, whether they are positive or negative. For the first vector, x component and y component, both of them are positive. For this component, for the second vector, BC, your x component is negative, but y component is positive. You agree with me? However, the vector expression remains the same. The vector expression is going to look like by plus yc is equal to bc. Are you with me? Now what I have to do is, I want to sum these components. And how do I sum these components? Dollars to dollars, pesos to pesos. Now please understand. Okay, okay. You agree with me? AX is in the x direction. XP is in the y direction. BY is in x direction. BY is in x direction. And YC is in y direction. You agree with me? So what I need to do is, I need to add all the subcomponents in the x direction. I need to add all the subcomponents in y direction, and that would tell me what is the final component of the resultant vector. I need to write this clearly. So this guy is in x. This guy is in y. So I'm gonna sum these. I'm gonna sum these, and that's gonna give me the total component in the x direction, and it's gonna give me the total component in y direction. Everyone understood here? So resultant, the way this is written is resultant in x direction, this gonna give you Rx, this gonna give you Ry. So Rx is 5 cosine 45 minus 6 cosine 30. Ry is equal to 5 sine 45 plus 6 sine. You agree with me? Please note, you cannot add these. Why you cannot add these? Because these are the magnitudes of Rx and Ry. These are not vectors. These are the magnitudes of Rx and Ry. You agree with me? Now use your calculators and tell me these values real quick. But if you want to write this expression down, tell me what is Rx and tell me what is Ry. Your vector equation to start with is AB plus BC is equal to AC. What is Rx? Negative. Ry? 6.1. So please note, these are the magnitudes of Rx and Ry. So how do I add? So let me tell you what it means. Which means, imagine you have this vector here. And imagine you have this vector here. Let me show you what this means. You have one vector here, you have other vector here. So this is your vector AB. And then you have this vector BC. And what you did all this sum. And you found out that at the end, you got Rx is equal to minus 1.66. So I need to be consistent. So I would basically show it like this. This is AB and this is BC. Now, Rx is equal to minus 1.66. This is the origin. This is where we started. This is where the whole thing began. Oh. If I go in minus 1.66 units in x direction, where is minus 1.66? If I go here, this is minus 1.66. And if I go positive 6.5, I reach the same point. You agree with me? Which means if I go something like this and this, essentially, if I close this vector sum, I have this vector, which is, this is actually A. I have AB plus BC is equal to this vector AB. You agree with me? Now, the question is, it's extremely important. You cannot add Rx and Ry. Why can't you add Rx and Ry? Because check, Rx is in the horizontal plane. Ry is in the vertical plane. If I ask you what is the magnitude of vector AC, what would you do? You have to look at the triangle which is shown over here. Can you see this triangle? So look at this triangle. And the magnitude of AC is Rx square plus Ry square root, which is minus 1.66 square plus 6.5 square. And why is it? I'm going to draw a slightly, so check this out. I'm drawing this picture here. Because what you have is you have minus 1.66 to 6.5. And if you want to find this magnitude, you need to use the Pythagorean theorem. Everyone understood this? Okay. Story does not take you. The other question is, what is the angle made by the resultant? What is the angle made by the resultant? It means in what direction the resultant is. Since you know this distance, you know 6.5, you know 1.66, you can easily tell me that this angle, this is the angle made by resultant, which is called theta r. Theta r is what? Tan inverse of 6.5 divided by minus 1.6. Or you can say 1.66. And then you say that this angle, can just show that this angle is in this direction. Are you with me? So whenever you are asked to find the resultant of vectors, step number 1 is to resolve the vectors in the same coordinates. Dollars to dollars, pesos to pesos. Add all the x's, add all the y's, and then find the sum. And if you want to find out the magnitude of the resultant, use the Pythagorean theorem, and you can find the magnitude. Take the tan inverse of Ry by Rx, and that gives you the angle made by the resultant. Everyone understood this? Any questions here? But we are going to do the exact same thing in 3D. Not now. We are not there yet. Now let's start with something else. So imagine basic concept of vectors. You are at point A. You want to go at point B. You are at point A. You want to go at point B. I'm going to set up my coordinate system. And here, what I would do is, I will introduce you to the concept of unit vector. So what is a unit vector? Unit vector only represents direction. The magnitude of unit vector is 1. Unit vector only represents direction. Now, what do I mean by unit vector representing direction? I say the unit vector in x direction is I, which means if you travel 1 unit, you have traveled 1 I. If you travel 2 units, you have traveled 2 I. If you go in the negative x direction, minus 1 I. If you go in negative x direction, minus 2 I. Because this is positive x, this is minus negative x, positive y, negative y. And in y direction, I'm going to call this j. You go 1 unit, it will be 1j. You go 2 units, it will be 2j. You go 3 units, it will be 3j. So if you go positive, it will be plus 1j, plus 2j, plus 3j. You go down, it will be minus 1j, minus 2j, minus 3j. Everyone understands this? So I and j are the unit vectors. They tell you the direction. They don't have a magnitude. They only have magnitude of unity. If I say go 1 I have specified the distance 1 and the direction positive x. If I say go plus, if I say go minus 2j, that means I have said go 2 units in negative y direction. So by specifying I and j, I have given the direction, the magnitude. Everyone understood this? Now I want to go from point A to point B, and I'm saying that B is at location 4, 3. Point B is at location 4, 3. To go to point B, you need to travel 4 units in x direction. You agree with me? And 3 units in y direction. So A, I'm going to call this C. So AC plus CB is equal to AB. You agree with me? Now I'm going to write this in a slightly different fashion. I'm going to say AC is 4I, CB is 3J, and my vector AB is nothing but the vector sum of these two, which is AB is equal to 4I plus 3J. You agree with me? Now, when you express vectors in terms of i's and j's, you know that 4 is the component of AB on x-axis. 3j is the component of AB, 3, on y-axis. Everyone understands this? Now my question to you is, what is the magnitude of AB? To find the magnitude of AB, you have to use the Pythagoras theorem, and that would be 3 square plus 4 square, and that gives you 5 square. 3, 4, 5 is a classic right angle triangle. This is all Pythagorean triangle. Okay. Now I want to ask you another thing. It's very extremely important. If you want to go from point A to point B, the obvious option is you can go from A to C, turn 90 degrees, go from C to B. The other option is, and we discussed this, you can simply go from A to D, turn and go towards B. But now I want you not to follow the path AC or CB. I want you to travel along AB. I want you to travel along AB. From the figure, you know that AB is the hypotenuse of the triangle. But what you don't know, in what direction AB is. I'll give you an example. So, and I think I can demonstrate this. So, this is my point B. This is my point A. I want to go from A to B. So, I will walk like this. First, I reached here. I know that this travel is around about x-axis. So I travel along x. I turn 90 degrees. Why? Because I have to travel around J. I travel around J. But now, what I want to do is, instead of taking this scenic route, I want to orient myself towards B and start walking 5 units towards B. The problem here, what I'm saying is travel 4 units in the unit vector direction of x. So 4x, 4i, 3j. But now what I want to do is, I want to find out, instead of going this way, I want to orient myself from A to B and just walk 5 units. How do I do that? To do that, I need to find out the unit vector in the direction AB. You agree with me? Unit vector in x is I. Unit vector in y is j. I, j. 4i, 3j. Now I need to go from A to B. Somehow I need to find out the unit vector in AB direction. This AB direction is not neither along x, neither or not along y. You agree with me? So what I need to do is, I need to find out the unit vector about AB. And how do I find out the unit vector about AB? To find unit vector about AB, remember, unit vector is always given as vector divided by the magnitude of vector. What do I mean by magnitude of vector? This vector is 4i plus 3j. So I'm going to call this AB divided by magnitude of AB. Divided by, what is the magnitude of AB? 5. Can you see? Magnitude AB is 5. So 5. So my unit vector is 4 by 5 I plus 3 by 5 j. You agree with me? you can ask me, what is this 4 by 5 I and 3 by 5 J? This is so important for you to know. This actually represents the orientation of this vector with respect to x axis. This represents the orientation of this vector with respect to x axis. This represents orientation of this vector AB. I'm going to call this n hat. This n hat. This is the unit vector n hat. Orientation of n hat with respect to G. And so this basically, so 4 by 5. So if you look at the 4 by 5, it only tells you that orient yourself. So 4 by 5 is nothing but also called as the direction cosine. So this guy is called as direction cosine. So this is also called as theta x, and we'll talk about this lot more detail in next class. But what I want you to understand is, if I want to tell you that, hey, so I would say 5 n hat is equal to AB. When I say 5 is the magnitude of AB, and n hat is the direction of AB. You agree with me? If you substitute n hat as 4 by 5 plus 3 by 5 j, you are going to get the exact same vector that you have 3i, 4i plus 3j. Everyone understood this? So what is the unit vector? Unit vector only shows you the direction. Direction means in what orientation you should orient yourself. Once you multiply the unit vector by the magnitude, you get the full vector. And you will deal with these vector representations again and again. One thing I want you to understand, that this is called as the direction cosine with respect to I. This is also called as the direction cosine with respect to J. So in other words, I can write this expression, and I'm going to talk about this a lot, but n hat is cosine theta xi plus cosine theta y j. Now, and this concept that I want you to kind of understand very, very clearly. It's not very intuitive. I gave you the value of n hat, and I said n hat is a unit vector. It only represents orientation, and I give you these numbers. Based on these numbers, I want you to tell me, if I'm facing this way, how should I change my orientation? Should I go like this? Should I go like this? What angle should I rotate? What angle should I rotate? I give you these numbers, right? I said direction cosine, right? Unit vector n hat is equal to 4 by 5 plus 3 by 5j. That does not solve my fundamental question. I want to go from point A to point B. Tell me how much I should orient. I give you 4 by 5, 3 by 5. I want you to tell me, just by looking at the numbers in the unit vector, what orientation actually orient. You are giving me the answer to the triangle. I'm asking you, I gave you the unit vector. I also gave you the hint that this tells me the direction of the cosine with respect to positive x-axis. This is direction cosine with respect to positive y-axis. Find cosine inverse of 4 by 5. That would be same as tan inverse of 4 by 2. No, 3 by 4. No, I know this. No, I'm fine. Wait, by the time I'm done with you, you try to ignore it. So, otherwise you won't. Okay, once again. So here is what I said. When I say travel 1 I, you travel 1 unit in I direction. That 1 is the direction cosine of I. 1 is the direction cosine of I, which means take cosine inverse of 1, which is 0. It means when I say 1I, it tells me that you are supposed to go, you should orient yourself 0 degrees with respect to x and march forward. When I say 2j, or when I say j also has, it's a unit vector 1. So cosine inverse of 1 is 0. So it tells me that you are in the y direction. Orient yourself 0 degrees with respect to y and march forward. Everyone understood this? Same thing I'm saying here. You have this unit vector. This is telling you take cosine inverse of 4 by 5. 4 by 5 is, I think, 36 degrees or something, right? 36.67. Orient yourself positive 36.6 degrees with respect to y, or with respect to x, and march in that direction. Same thing here. This is 3 by 5. What is cosine inverse of 3 by 5? 56, right? So 53 degrees. So this is exactly what it's telling you, that orient yourself 53 degrees with respect to positive y-axis and march forward. That is what it is. Everyone understood? Really important. I'm going to quickly repeat what I said and then I will wrap. We talked about vectors. Vectors have magnitude and directions. Vector sum is an algebraic sum, but dollars to dollars, pesos to pesos. If you want to find out the resultant, you need to resolve the force along x direction. You have to resolve the force along y direction and then solve, add x's, add y's. Everyone understood this? If you want to find out, if I give you multiple forces or multiple displacements, ask you to find resultant, you have to first place the origin where the vector starts. See if your x-axis and y-axis components are positive or negative, and then add dollars to dollars, pesos to pesos. If you want to represent this as a vector sum, then you need to multiply these magnitudes by the respective unit vector. What is the unit vector around about x? I. What is the unit vector about y? J. So your final resultant is going to be as shown over here. Everyone understood this? If you want to find out the angle made by the resultant, you find out tan inverse of Ry by Rx. Last thing that we talked about is concept of unit vectors and what these unit vectors represent. Okay. Homework. Remember, we are going to have a quiz next class. So the very first problem I'm assigning you as a homework. Yeah.
The chapter two problem, yeah.
Okay. Let me tell you. Go to Canvas. You see two files. One file is the PowerPoint presentation which I'm using. And the second is the solution, the PDF. I have given you the answer to this problem. I have also given you the solution to this problem. Everyone understood this? Don't look at the solution and try to work out the problem. First, try to solve the problem with the process that we talked. Everyone understands, right? You have a vector display this point. See if you are getting the same answer. If you get the same answer, you are golden. If you don't get the same answer, look at the solution and see where you went wrong. Next week, you are going to have an in-class quiz. And depending upon my mood, I'll give it to you in the beginning of the class or at the end of the class. Whenever the attendance is the lowest. If I see at the beginning the attendance is the lowest, these students they come on time. That is the time I'm going to give you the quiz. If I see half of the students leave towards the end of the class, then I will give you the quiz at the end of the class. So attendance is required. You won't be able to make up the quiz unless you have a valid university excuse. And what I will do is, I will upload the video lecture on campus. With that, I'm going to stop here.